arc length. Okay, so this one we're kind of putting together a few pieces of stuff that we already know, such as like the ratio and circumference. So in circle J with measure of angle HJK, yes, I'll keep it in this color, HJK being 144, and HJ being 13 units. I'll do that in purple, I don't know. Find the length of arc HK. So we're finding the length of this arc. Okay, so essentially what we have to do here, I don't know why I keep exiting my annotations. I should not do that. Essentially what we have to do here is take this 144 degrees, the measure of the central angle, and then divide it by 360, and then multiply it by the circumference. And circumference, if you remember, is 2 pi times the radius. And in this case, they gave us the radius is 13. I guess I could write this out in words first so that you actually have a formula to plug stuff into. So I'll just write it over here on top. Central angle over 360. And then you're going to take that and multiply it by 2 pi radius. So as you can see, this is the formula I use. I literally just plugged in, instead of the central angle, I put in 144 because that was your central angle over 360 times 2 pi, and the radius, I just replaced the radius with the number of the radius, which is 13. So this is the formula you shall use for this section. So the arc is equal to this. And I'm just going to type that into the calculator because, I mean, that's what you do, right? Like, we don't know this off the top of our heads. So we're going to round it to the nearest hundredth. So let me just type all of that. 144 divided by 360 times 2 pi times 13. So I got 32.6725, whatever. We're rounding it to the nearest hundredth. That's 2 decimal places, so 32.67. 7 stays as a 7 because the following number, the 2, is a small one. So 7 stays as a 7. 32.67. Remember, my answer is different than yours. It's not moving away. Okay, whatever. Wait, I actually can't make it. Okay, hold on. All right, that was weird, but now we have our answer. I'm going to submit it. Okay, next problem. Let me erase all of those drawings. All right, so for this one, encircle T with measure of angle STU is equal to 68. And ST is 13 units. We're going to find the length of arc SU. Okay, so all we have to do is plug it into our formula. Oops, this is the formula from the previous one, so let me erase that. Okay, so central angle is 68 this time, over 360, multiplied by the circumference, which is 2 pi times the radius, which is 13. So this is the formula we're using. Same formula for all these problems. And then I'm going to type that into the calculator and hope that my calculator doesn't do weird stuff again. Okay, so let's put 68 over here. So 68 over 360 times 2 pi times 13. Okay, and it gave me 15.428. We're rounding it to the nearest hundredth, which means we want 2 decimal places. And then that would be 15.43. So it's a 3 because 8 is a big number. So we will round the 2 up to a 3, 15.43. 15.43. Any questions about this one? 15.43. I guess I should just scroll like that so you can see my rounding. Cool, it's not showing me the green check mark again. But if you go here, you can see it says 2 out of 5 now, which means we got it right. Let's do one more example. Cool, so let me erase some of that stuff. So erase all that. Okay, so now all we can see is that formula. So we have a measure of HJK, that is our angle, that's 42. And then we have HJ is 7. We're going to find the length of the arc, which is KH. We're going to round it to the nearest hundredth as usual. So let's plug it into our formula. Central angle is 42 over 360 multiplied by, that is multiplying, multiplied by 2 pi times the radius. Our radius is 7. So then let me type this into our calculator. And we get 5.13. Rounding it to the nearest hundredth is just 5.13 because after the 3 comes a 1. 1 is a small number. So you're just going to keep the 3 as a 3. So 5.13. Okay, let me type 5.13. Any questions?